maximum and minimum values is what we are going. Now we are going to see examples. In the previous lessons, we saw that we are just setting the formula. Now we are going to see how do we get those values in actual sense. Now these ones of numbers. The next lesson we are going to get how do we are going to see how we get those ones of expressions. Then from there we shall come to the range, limits, and intervals of actual set. So now we come to this, start with this. Recall from the last lesson that if x is a number and x is the maximum absolute error given by this square n, the number of decimal places, then x max, we get the exact value plus the absolute error, the maximum, then we get the x min, we get the x, then minus the x. This one means a maximum absolute error. The formula is there. Let us see these examples. Find the maximum and minimum values of the following. So they give us this. Your task is to first define how many decimal places is this number given to. You see, I have this. I'm going to give you this as your exercise. You will use your inner eye in this, and I'm going to handle this and then this. When I look at this, I start it's given to one decimal place, meaning that n is equal to 1. So meaning the maximum possible error in x is going to be 0.5 times 10 power negative 1. And so this one is giving me 0.05. So meaning that now my x max will be given by the exact value, okay, given by x, then plus e of x, which will be now 0. It will be 5.2, then plus 0.05. This one is giving me 5.25. That is done. When I come to x mean, my x mean will be given by x, then minus the maximum possible error, 5.2 minus 0.05. And so this one will give me 5.15. So I think this one is the maximum, and then this is the minimum value. Now try this. Use your inner eye and you see how many decimal places you have there. Okay, when I come to this, you start this one is given to 1, 2. So mean that here our n is going to be 2. So now means that my maximum possible error in z is 0.5 times 10 now. Power negative 2, which will give 0.005. Now, means that now my z max, which is given by z plus e of z, this would be our z is negative 1.45, now plus 0.005. So here I don't just do anything. If you don't see that, you don't feel shy to get your calculator and press this value, this one you are subtracting with this. So you get a press negative 1.45 plus 0.005, and so the answer will be having. The answer here is negative 1.445. This is your z, the maximum value of z. Then if you want the minimum value, you just get z min will be now z minus now the maximum possible error or the maximum absolute error in z. So if you put your value as negative 1.45, then minus 0.005. If you can't see that, get your calculator and plug it. So this will be negative 1.455. So if this is the hard for you, you get your calculator, then you say minus. So now I think this one is bigger than this because when we have negative numbers, that which is bigger inside in magnitude is going to be less. So you see that this one is in magnitude is less, but when you have it as a negative, it's going to be bigger than this. Okay, so that's how you get the maximum of z and the minimum of z. I think now you can try this out. Let us see the limit, range, and intervals of actual z. These are values that define a region within which the exact value of a function or a number, even when you have a number, there's also a function, but those ones are called constant functions, lie. Beyond these regions, you cannot find the exact value of a number x. Limits, these are minimum and maximum values of the region. So you know a region, you know why when you're doing quite easy, define the region from something to something. So the upper limit is given by the maximum value. So if you have a number x, then it will be plus, that's how you get the maximum value. Then the lower limit will be given by the minimum value, which we get like that. Then the range of x, where we expect that range, we give it like this. Then the interval, in most cases, some people treat the interval to be the same as the range because it's that there we are closed. These ones mean that we have a closed interval. Okay, given that x is equal to this, state the maximum absolute error. So now in our solution, state the range, the limit, and then the interval. From there, I first get my x, so my x is 9.155. So now this one has been given to 3 decimal places. 1, 2, 3. So meaning my n is going to be 3. So from there, I first calculate my E of x, the error, the maximum possible error. So from here, I'll come and say my E of x will be 0.5 times 10 power now, and that is 3. And this one is going to give me 0.00005. Then after doing this, in order to get the maximum, to get the range, the limit, and so on, you need the x maximum. So my x max, say this is the same as x plus e in x, which will give us 9.155 plus, now we add on this 0.0005. If you can't add this properly, don't feel shy. Pull out your calculator and you press it. 9.155, these are the 3, then that 5, that is 9 max. Come to, and now we say the limits. And we said, remember, we said the x maximum is going to give us the upper limit. Then here, I come for my x mean. So my x mean, we said it's x minus e of x. So we are going to be having this value, 9.155 minus 0.005. And here we get 9.155 minus 0.005. The answer we get here is 9.1545. This is our minimum value. This is our maximum value. Then part A, part B, if you have set the limits, have my upper limit. Upper limit, we said is the same as x max, and it's going to be this value. And I come to my lower limit. It's going to be, we said it's the same as x mean, the minimum value of x, which is 9.1545. As simple as that. Then when we come to our range, we say we give our range in this form, bx mean, this will equal to x, this will equal to x max. Our minimum is 9.1545. This will equal to the value of x, 9.1555. That will be our range. Then come in statistics. So this would be about 9.1545, comma 9.155, then another 5. That would be that. So if they ask you to get the minimum, the limits, the interval, then the range, that is the interval will give the square brackets that you've seen. That's how you get the maximum possible error or the maximum absolute error. Now, I think you've seen that the more we give, the more number of decimal places we have, the less and the less this maximum possible error is going to be. So in simple terms, for better accuracy, you give a number to more decimal places. That's what it indicates here. That's it, members. Now we are going to see the next lesson, the maximum and minimum values of expressions or functions. See there, we have been seeing here for just numbers, functions which are just constants. So we are going to see now expressions. They are being careful. See you there.